Hey, Nathan here from PH Studios, and welcome back to another Tower Defense Engine tutorial. In this tutorial, we're going to cover the Tower class Part 2 and get that finished up. Okay, so the first, we already did all the properties and the writer and the reader, and we did the clone method at the bottom. So now we're going to fill in the rest of the methods that we left blank. So the first method that we left blank, going from the top to the bottom, is the level up method. Now the level up method is going to work by checking to make sure that you have a positive level. You cannot have a negative level, and it'll check the initial statistics and upgrade statistics on the tower to see if they're not null, because we'll be using those in our mathematics to add those statistics together, and if they are null, it'll throw an error, so we need to check those. So if we have a positive level and initial statistics is not null and upgrade statistics is not null, then we can level up. So level up by setting the current statistics is equal to tower statistics dot add. We have a add method in the tower statistics, and it accepts initial statistics, and we have two overloads for this method. We have an upgrade statistics or another tower statistics. We are going to use the upgrade statistics, which we need to multiply by our level. So we need to call upgrade statistics dot add, dot multiply. We need to multiply this from our current upgrade statistics, comma, our level. Okay, so what this does is it will add the initial statistics with our upgrade statistics for our appropriate level. We are using a static leveling approach. For every level you gain the same benefits. Your health will increase 10, or your damage will increase 10 every single level. No matter if you're level 1 or 100, it will always increase your damage by 10. So we have a static way of leveling. We do not have a, well, you gain 10 damage for level 1, and then you might get 9 damage for level 2 and all that stuff. It's just a static value, no matter what our level is. So we multiply our upgrade statistics, the delta, what our statistics will change between each level, then we'll multiply that by our current level, and then we add that to our initial statistics. The base that the tower has whenever we bought the tower, the base statistics, we add that to our upgraded statistics, and that's what gives us our current statistics. Alright, so that method is done, so scroll towards the very bottom and you will reach the initialize method. And let's go ahead and get that started. So initialize is going to be called, and we're going to pass it the map. Our map is going to initialize our tower. So we need to make sure our tower is aware of the map, and then we need to check if not string dot is null or empty thumbnail asset. So if the thumbnail asset is not null or empty, we need to set the thumbnail texture is equal to content manager. We pass the content manager to the method. So thumbnail is equal to content manager dot load. It's a type of texture 2D, and we load it by using the string dot format. And wherever you want to store your textures, and this is completely up to you, And then whenever you have some variables, you can add it in between the curly brackets, like I did the curly bracket 0, curly bracket, and curly bracket 1, curly bracket. That's for a variable for the string.format, which we'll pass here. So we provide the object after the first comma. We provide the object that we want to fill in this portion. So map.name. That means that the map.name will replace my highlighted section of the string. Now after the second comma, it will replace this one here, which is the thumbnail asset. Alright. If not string.is null or empty texture asset. So if our texture asset string is not null or empty, we need to do the same thing. Texture is equal to content manager dot load texture 2D, and we need to pass it the same thing, string dot format textures maps opening curly bracket 0, closing curly bracket, opening curly bracket 1, closing curly bracket, comma map.name again, comma our texture asset. Alright, so when we load the texture, we also need to load our origin. Origin is equal to new vector 2 texture.width divided by 2, comma texture.height divided by 2. So the center point of our texture will be our origin. Alright. Now, we need to have, whenever you click a tower, it will show its radius, its attack radius. So we need to have a texture to handle that. So, just like the other two if statements, we need to have an if not string.is null or empty radius texture asset. So if the radius texture asset is not null or empty, we need to do the same thing. Radius texture asset is equal to content.manager.load and the rest of the stuff that you've seen before. Now I'm going to copy that and I'm going to set its formatting appropriately. So just like we did before, we need to load, and this needs to be loaded in the texture, not the asset. So we need to load our current radius texture, and we get that from the textures folder, the maps subfolder, the maps name subfolder, and then our texture asset for our radius. Alright, so now we loaded all of our textures. Now we need to set the bullet base dot initialize map content manager. Timer is equal to current statistics.speed. So that's the attack rate. The towers attack on their own, so we need to set a timer on when they can attack. So the smaller value that the attack rate is, the faster it can attack. And then once everything's set up, we need to set initialized is equal to true. Okay, so now we have another initialized method that just accepts a map. So now we need to set map is equal to map initialized is equal to true, and bullets is equal to new list of type bullets. Alright, so that's the two initialize methods. Now we have set location. Now the set location will set the tower's location and change its rectangle and change its position object as well. So we need to check first if map is not equal to null, because we will need to convert our location to world coordinates. So if map is not equal to null, we need to gather a point P is equal to map.toWorldCoordinates, open parentheses, map location dot x, comma map location dot y. So we need to convert this location, which is like a map location. It's the third column and fourth row down. So we need to convert that 3, 4 to 200, 150, for example. So we need to convert that to world coordinates. So we get that into a point value called P. Now we need to set the rectangle is equal to new rectangle P.x, P.y, texture.width, texture.height. Alright, now we need to set the position is equal to new vector2 P.x plus we need to offset our position based on our origin.x, P.y plus we need to offset our y's position based on our origin.y. Alright, so that is the set location. We need to convert our map location to world coordinates. Then we need to update our rectangle object and our position object, and we need to offset our position object by the origin, but not our rectangle. Okay, now place tower is just a very simple method. It will place the towers by set it is place is equal to true. That means we can select the tower, we can see our attack radius, and we get our buttons to update, upgrade, or sell the towers. This also means we just bought the tower, so we need to set the total cost is equal to cost. Alright, next up is the upgrade method. Whenever you select a tower and you have the button that says upgrade this tower for the price of X, that will allow you to upgrade the tower by increasing its level. And we also need to update our total cost by adding the upgrade cost of our tower. So total cost plus equals and our upgrade cost, and the upgrade cost is determined by our current level plus 1, closing parentheses, times our cost of our tower, closing the second parentheses, and dividing that by 2. And we do integer divide. We don't need a floating point as our cost. So that is our total cost, and you can make that into a property if you want to, because that's just a static formula that we can use. So you can make that into a property. So we have a content serializer ignore, because it's a property we need to ignore it. And it's a public int upgrade cost. And it just has get, and then we just cut everything after the plus equals, and then paste it in the get. And then after the plus equals, we need to have a return up there. And after the plus equals, we need to say upgrade cost. So you can do it either way. You can have a property, or you can just leave it like I had it before. The property will make it easier, so I'll just leave it like that. Alright, so now we have an update method, and the update method is, anytime we have a game element, we need to update and draw it. So update, we need to perform a few things if it's placed, and if the timer is less than 0, we need to fire the bullet, and all that kind of stuff. Alright, so if the tower is placed, we need to set placed time plus equals, we need to cast as float the game time dot elapsed game time dot total seconds times session dot singleton dot speed. So we just need to increment our place time by the elapsed game times total seconds, and then we'll multiply it by the speed of our game. If timer is greater than 0, that means we cannot fire yet, so we need to fire, or we need to decrease the timer. Timer minus equals, cast as float again, just like we did above, game time dot elapsed game time dot total seconds times session dot singleton dot speed. And like I said in the very beginning of our series, you can have this set globally. You can have it change our game time globally. Or you can do the way I'm doing it, is to multiply everything by the session.speed, and then you can have access to the raw game time if you ever need it. So either way, you can modify the game time before it gets to any of your objects. Just multiply it by the session speed and update the game time object with the appropriate speed, so you don't have to do this on every single object and class. Or you can do it the way I'm doing it, is to leave the game time alone, and just every time you want to have an object or something being influenced by the change of game, you can do it this way. Okay, so now this tower class is not a derivative of clickable gameplay object, but we do have mouse elements that we brought from the clickable gameplay object into this. So we need to call UpdateMouse. Game time, and then the mouse is active mouse. Alright, so now we have bullets. So we need to do for each bullet, for every bullet B in our bullets list, we need to update our bullets. So call b.update. We pass it game time. So we need to loop through every bullet in our bullets list and update every single bullet. If target is not equal to null, we need to call update target game time. Else, if our target is null, we need to find a new target. Target is equal to find target. If we perhaps kill the current monster we're looking at, we need to find a new one. Alright, so that's pretty simple for the update method. Now we need to focus on the update target method. So now, update target we will fire if our current timer is equal to or less than 0. So our timer has elapsed, we are allowed to fire, and if the monster's distance is within our radius still. Remember, it focuses on a monster, and if that monster walks so far from our tower, and it's all of a sudden outside of our radius, we cannot hit that monster anymore. So we need to calculate the float distance is equal to vector2.distance target.position, comma, position. So we just need to calculate the distance between us, the tower, and the target, the monster we are focusing on currently. So if that distance is less than our radius, if, two opening parentheses, distance is less than or equal to our current statistics.radius times session.singleton.map.tile.dimensions.x. It doesn't matter if it's x or y, your tile dimension should be the same, so I just chose x. And target.isActive if we can fire, if the monster is within our radius and it concurrently has life left, so it is still active. That's part 1 of this if block. Part 2 is we provide and, another opening parentheses, an exclamation point, so we need to negate our current testing here, not map.toMap coordinates, open parentheses, we need to cast this as an int, target.position.x, comma, cast as an int, target.position.y, closing parentheses, dot equals, opening parentheses, map.castle location. Closing parentheses, closing parentheses, closing parentheses, closing parentheses, and then opening, closing curly brackets. Okay, so this, what it just did, this is part 2 of our if statement. We need to convert our target's position to map coordinates. Our target's position is currently in world coordinates. We need to convert it to map coordinates. Now, we need to test to see if it is not equal to our castle location. Whenever the monster reaches our castle location, we cannot fire on that monster anymore because it has reached the end and we have had our health decrease and all that stuff. Alright, so this is a pretty complex if statement here. So all this says we had the potential to fire on the enemy, but we also need to check the timer, which will do that in just 1 minute. Float rate is equal to bullet base.speed vector2 d is equal to vector2.add our target position comma vector2.multiply our target velocity comma distance divided by rate, 2 closing parentheses, minus position, semicolon. Okay, so let me explain this line right here, the one that I just coded. Take a first-person shooter for an example. Those of you that have played first-person shooters and have used a sniper rifle in a first-person shooter, you will notice that you should not fire at where the enemy is right now. You don't want to have the cursor directly in the center of the enemy's texture. You want to fire where you think the bullet will be given that distance between you and the player. So you do not have your cursor in the middle of the texture. You have it a little bit ahead of where they're running or walking. And if they're running, you want it a little bit farther ahead, and if they're walking or standing, obviously if they're standing still, you can have the cursor in the middle of the texture. But if they're moving, just like the monsters in the tower defense game, they are moving. So if the enemy is moving, you want to position the cursor a little bit ahead of their walking distance. You do not want to fire at where the enemy is. You want to fire at where the enemy will be by the time that the bullet will get to get to that position. We're taking the same approach with the tower defense. We will not be firing at where the target is right now. We will be firing at where the target will be. We use a very simple physics formula to determine that. Distance is equal to rate times time. So we have the distance between ourselves and the target. And we have the rate. Our rate is our bullet speed. Now we need to get time. The time it will take for the bullet to come from our tower to where our target is. We need to get that time value, and we get that by we take distance divided by rate, and that gives us time. Now we need to multiply that by the target's velocity, so that will give us its future position. Now this does have some drawbacks. If the monster is coming across a corner, like it's turning left or right, this will not be accurate because it will not take account of the change of direction. It will just think it's going to keep on going straight. But this will add the velocity, which is multiplied by the time it takes for the bullet to get from our tower to the monster. That way it will give us its future position. So that's what this line does. So now we need to set rotation is equal to cast as float math.atan2 arctangent 2 d.y comma d.x. We want to rotate our tower where we want to fire. So we update its rotation. Now, after all this, if the tower is looking at the monster, you still want it to rotate. So you want to give it some sense of, hey, I'm aware of this monster. If it just sits there, you do not know if it's aware of a monster or not. So it will always rotate depending on if it can fire or not. So now we need to check if timer is less than or equal to 0. So if we can fire, bullet B is equal to bullet base dot clone. We need to clone the bullet base and call b.fire, and we need to pass it our tower. So we need to pass it this. Bullets.remove, bullets.add B. We need to add that bullet to the bullets list. And we need to set timer is equal to current statistics.speed. Okay, all this stuff, and then we have an else block here. Target.die event minus equals new event handler, open in parentheses, m underscore die event, closing parentheses, semicolon. Target is equal to null. This means that that target is no longer valid. It is probably outside of our radius, or it has reached the map's castle location, or it's no longer active. In either case, we need to remove ourselves from the target's die event, so we are no longer notified when the target is killed and then we need to set it to null. Okay, so now we need to have a find target method. We need to get wave. We need to get the active wave is equal to session.singleton.map.active wave. Monster M is equal to null. Float distance is equal to 0. New distance is equal to 0. If active.monsters.count is greater than 0, so if we have active monsters in our active wave, we need to check every monster. M is equal to active.monsters bracket 0 closing bracket semicolon. Distance is equal to vector 2 dot distance squared. Opening parentheses, m dot position, comma, position. So why are we using distance squared? Well, right now we do not care if it's a certain distance from our current position to the current monster we are looking at. All we are worried about is if monster A is closer to us than monster B. So we can determine the same thing with distance squared, which is incredibly fast, versus distance, which is slow. But here we do need to have the exact distance between target and ourself. Here, no matter if it's squared, not squared, we can determine if the monster A is closer to us than monster B, no matter what. So we'll go for the faster way, which is just distance squared. For int I is equal to 1, semicolon, I is less than active dot monsters dot count, semicolon, I plus plus. Closing parentheses, opening and closing curly brackets. Inside of the for block, let's set new distance is equal to vector 2 dot distance squared, opening parentheses, active dot monsters bracket I end bracket dot position, comma, and our position. If new distance is less than distance, we need to set distance is equal to new distance, and our M object is equal to active dot monsters bracket I end bracket. So that monster we are looking at in this iteration becomes the new candidate for our target. Okay. Now if, after all this giant if block, we press enter a couple times, and now we have another if block. Two opening parentheses, math.square root our distance. So we need to convert that distance squared object to distance. So this is where we need to get the appropriate distance. So if we square root the distance, and that's less than or equal to our current statistics.radius times session.singleton.map.tile dimensions.x, and opening parentheses, m is not null, and m.is active. two closing parentheses, opening closing curly brackets. m.die event, we need to sign ourselves up to that monster's die event, and m.die event. Just like when we remove ourselves from that notification in the update target method, when we find a new target and that target is a valid candidate, we need to sign ourselves up for that notification that that monster has been killed. Now, we return M after that. So return M, we are done. After this if block, we have an else. Else, return null. We did not find a valid object, so we just return null. Okay, so here's that m.die event. Whenever a monster is killed, we need to set target is equal to null. And that will allow us to scan for a new target in our next update loop. It'll scan for a new target and everything will be good. Alright, UpdateMouse. Now this is going to be very similar to the clickable gameplay objects class, but we want to strip it as much as we possibly can and just use what we need from that class. Bool intersect is equal to ActiveMouse.rectangle.intersects, opening parentheses, our rectangle of our tower, closing parentheses, semicolon. If the intersect object we just created a line above, if that is true, or opening parentheses, ActiveMouse is not equal to null, and by the way, this is the property ActiveMouse, so be sure to capitalize the A. We do not want to look at the mouse that we pass into this method. We want to look at the property in this if statement. So if the property's ActiveMouse is not equal to null and opening parentheses left state is not equal object click state dot normal. Three closing statements, closing parentheses, opening closing curly bracket. ActiveMouse, the property, is equal to ActiveMouse, the field, or the parameter we passed. So, ActiveMouse with a capital A at the beginning is equal to ActiveMouse with a lowercase a. If that confuses you, you can change this to something else. So we have an if block, ActiveMouse, the property, dot left click, and opening parentheses, left state is equal to, double equal sign, object clicked state dot normal, or left state is equal to object clicked state dot released, two closing parentheses, opening closing curly brackets. So if that's the case, we need to set left state is equal to single equal sign. We need to assign it the object clicked state dot clicked. So this is when we click the tower. If left click event is not equal to null, we need to let everybody know that signed up to this event that, hey, we left click this tower. So left click event, open parentheses, we need to pass it this, comma, event args dot empty, closing parentheses and semicolon. So first we need to check if we have people signed up to this event. If we do, we need to let everybody know who signed up to this event hey, the tower has been left click. So we need to call the user interface. We need to let them know to show the attack radius. We need to call the command info bar that's signed up to the event, so it switches the buttons and it switches the UI blocks to show that we can upgrade the tower or sell the tower. So those are the things that sign up to this event. Okay. So now we have an else if active mouse the property dot left release and left state is equal to double equals object clicked state dot clicked. We need to assign left state, so single equals object clicked state dot normal. Okay, so that was all in one giant if block right here. Now we need another giant else block for if active mouse the property is not equal to null. We need to assign active mouse the property is equal to null. If you're not sure what all this means, check my YouTube channel or my website. There is a clickable gameplay object tutorial that covers the main clickable object class that goes into more detail, but I explain how all this works. Basically, we have a mouse texture and a tower texture. If they intersect, or we have an active mouse and the left state is not normal, we update the mouse. We need to check its left state or left release. If the textures do not intersect, then we set the active mouse is equal to null, because we don't have an active mouse for that tower. Alright. I know this is a lot of code, and I hope I'm explaining everything for you. If not, just let me know in the comments, or if you have any questions, just let me know, and I'll be glad to help you out. I don't want to make this a 2-hour video for just one class, so I'm trying to balance it on, do I want to talk about everything or do I want to talk about nothing, so I had to pick a middle point. Now we have two methods left. They're pretty simple. You basically know what draw does. We just need to draw the objects. Okay, so the draw method, we need to draw the bullets. So for each bullet B in bullets, we need to call b.draw. We need to pass a game, time, and sprite batch. After we draw every single bullet, we need to draw our tower. So sprite batch.draw texture position null comma color.white comma our rotation comma our origin comma 1.0f comma sprite effects dot none comma 1.0f. Alright. So you can hover over that line and it'll tell you which overload is being called. The null I provided was the source rectangle. It just tells it to draw the entire texture. The first 1.0f is the scale. It's going to be 100%. The texture is going to be 100% scale. And the last 1.0f is the layer depth. Alright, that's it for the draw method. Now the draw radius. Float, scale, is equal to, open in parentheses, current statistics.radius times session.singleton.map.tileDimensions.x, closing parentheses, divided by float radius texture.width. Semicolon. Alright, so now we need to call the sprite batch.draw, opening parentheses, our radius texture, comma, position, comma, null, comma, color.white, comma, 0.0f, that's a rotation, comma, new vector 2, opening parentheses, a radius texture dot width divided by 2, comma, a radius texture dot height divided by 2, closing parentheses. And that is our origin for the radius texture. You can make that into a property if you want to. Comma, our scale times 2. Comma, sprite effects dot none, comma, 1.0f, closing parentheses, semicolon. So our scale, we need to multiply it by 2 because we're using the radius. We need to multiply 2 to get the diameter for the scale. Alright, so I copied the reader and explained that in the first part and the clone method. So, that's pretty much it for this class. It's a long tutorial already, and I didn't explain everything in as much detail as I wanted to. So if you have any questions, just let me know, and I'll be glad to help you out. Alright, so the next tutorial will be next weekend, and we'll continue on with part 2 and fill in all the methods. By the way, in the initialize method, we do pass in the map, and it is being set. So, you saw me use session.singleton.map.tileDimensions.x a few times. If you want to do a find and replace, session.singleton.map, you can copy that, go to Control F, you can paste it in there and go to quick replace and just replace it with map. And you want to find options and current document and match the case and then replace all, and then that way it'll use the map we passed in. Either way it will work. They both achieve the same result. We can save this class, and that is it for this video. Alright, so I'll see you next weekend for another part 2, which will probably be another 50-minute video. And I hope you enjoy this. Again, if you need anything else explained in more detail, just let me know, and I'll be glad to help you out. It's already 50 minutes, or 47 minutes, the last time I checked, so it's already pretty long, and I didn't want to spend any more time on it. I hope I covered everything that's important. I hope I covered everything in great detail, and I hope you understand everything. Like I said with the mouse, UpdateMouse, if you're not quite sure on how this works, check out the clickable gameplay object. And it's a lot more code in that because I stripped out most of it just for the tower class. I mean, there's a right click and all that stuff as well. But go ahead and check out that tutorial and see if that helps you out with how the clicking works. Alright, so I'll see you next weekend. Thanks.